Good morning, everybody. This is for this lesson today. We are going to start getting into the construction sequence and what is involved in the construction of many of our buildings that we see today. So, the construction industry is really a major contributor to the U.S. economy. According to a 2019 statistic, the industry has more than 680,000 employers with over 7 million employees and creates roughly about $1.3 trillion worth of structures every single year. So the construction industry is broken down into several classifications. You have your residential, you have your commercial, you have your industrial, and you have your civil construction. Your residential construction really is simply your homes, your single-family homes, your small apartment complexes, condos, areas of that nature really would fall under those types of classifications. Your commercial will fall under all of your offices, your apartment buildings, hotels, stores, shopping centers, malls, maybe even some factories. That's really where those are coming from. Your industrial is a lot of your refineries, your paper mills, and much larger structures. Your civil construction is all of your highways, your bridges, your airports, your dams, so on and so forth. In the HVAC industry, we will work on all of these different classifications. If you could think about it, HVAC is pretty much everywhere. We're not just dealing with just heating and cooling a space, but we also deal with ventilation. We also deal with exhaust. We deal with every aspect of some sort of air movement and air conditioning of some sort. So with the construction process, the first thing that has to happen is you got to have some sort of idea and a design. And that design comes from the owner. They definitely come to an architect with some sort of idea, some sort of concept that they want to have built. Now that could be a home, that could be a factory, it could be a business. It's unlimited. So the first thing that they do is they're going to contact an architect. Okay, an architect is going to have not only artistic ability, but they are going to have construction knowledge and are going to be able to take those two areas to come up with a design of what this particular owner may want to have. So architects not only take care of what the building is going to look like, they're also going to help determine the amount of space that's going to be needed for this idea. It's going to help decide how many rooms you're going to need, the type of building. Is it going to be a wood structure? Is it going to be a brick structure, concrete, you name it? And also going to give you a rough idea of how much it's actually going to cost to put the building together. Okay, they are also going to take everything and they're going to put it onto a sketch, basically describing the building before it's actually start to build and before they start putting into an actual final drawing of what the building is actually going to look like. So what they may do is, as you see in this picture here, kind of like a balloon sketch, really kind of something very simple. That way, as it goes tossed back and forth between the owner and the architect, things can be changed, things can be moved, and then eventually those balloon sketches become more in-depth into actual prints and layout of what the building might look like. In this case, this is actually a balloon sketch of a duplex home where basically each room is just a mirror off of the other. So before a lot of our details in a blueprint and in sketches are actually finalized, you got to have other professionals as well come in and give input and feedback and see what else has to happen before you actually start to break ground. Now, those other professionals are obviously your HVAC contractors, plumbing, electrical, fire suppression, if that's a part of it. You're going to have roofers, you know, a general contractor. All of these guys are going to come in. They're going to be reviewing the prints to get an idea of what has to be done on their end, and they also have to be able to follow all of your building codes, okay, that specify for their particular area of construction. A lot of our codes that are followed comes from our International Mechanical Code Book, comes from our NFPA code books, our International Residential Code Book. The list just goes on. Okay, really where these codes come from, it comes from really the International Code Council, and they publish several different code books every several years with any changes that have been made. So the industry is always changing and developing, so contractors, general contractors all need to kind of stay up with the newest codes and make sure that they're followed. So with your local codes, they are really based off of the standards set by the International Code Council. Okay, your local codes can be stricter than what is in the International Code Council or an International Mechanical Code, but they cannot be less strict than what is in those books. So when a piece of property or a home is being built, you have your code officials that have to as well review your plans for before the construction is actually to begin. They also come out and they will inspect the construction process as it is ongoing, and obviously if there's any sort of issues, it's going to be brought to probably the general contractor attention, which will then obviously go out to all of the other contractors that are out there to make sure that it's actually fixed. If it is not fixed, construction sites can be shut down simply due to the fact of some sort of code violation, or maybe even OSHA may come out. So there's a lot of things that have to come into play when the buildings are actually starting to go up. We also need to pay attention to a lot of the zoning laws in the area of where this building is going to be put. Okay, your zoning areas is basically, it divides your community into different zones where only certain types of buildings can be put up. So like in a residential area or a residential neighborhood, it may not be permitted to put up a commercial building in that area. And if that ever does happen, there's other procedures that has to happen in order for that to actually occur. So the building department usually requires specific procedures to be followed. First thing, obviously, you got to have all of your building permits. Without the building permit, you cannot start to build. Okay, your building permits also notifies the building department of your planned construction. It's on the books. They know that it's there. They know that it's going on. Once the building is completed and it is ready for occupancy, the building officials come out, they inspect it, they sign off on the building, and then they issue what is called a certificate of occupancy. And that is basically nothing more than an issue that says, hey, the construction has been approved, you're good to go. But obviously, with all of that, there's more to it than just, hey, getting permits and contractors. You got to have the money. You got to also have the money to be able to even do the construction. Okay, so beginning after whatever your design, your finished design that you want to be. Now you got to go to your lending department, your banks, and you got to get approved for your job. Okay, most common form of those for homes is obviously through a mortgage. Okay, after your financing is obtained, the contractor is going to be then hired. Okay, and then they are responsible for the overall project completion. They're going to hire subcontractors to complete individual parts of the project, just like I said, plumbing, HVAC, fire, electrical, landscaping, you name it. So this is a little diagram of what we're just talking about. Okay, so you have your owner, they go back and forth with their architect. Okay, that architect has their drafters, their mechanical engineers, their electrical engineers, structural engineers who put all these plans together and come back to the owner with, hey, this is what we think. The owner either approves it or doesn't approve it. And if it's approved, now they go to your lending institution with all the proper documentation where they get the financing to build this building. Once that's all taken care of, the contractors are now hired. Okay, the contractors will then be able to have their estimators, their superintendents, their crews, and subcontractors all involved in making the job happen. Once the building is actually complete, the building code officials, they are going to come in, they're going to inspect the building as it's being built and as it's finished to sign off on it and give the building a certificate of occupancy. So when it comes to the drawings of these things, this is where a lot of our architectural drawings come from. They use what we call isometric drawings. These are vertical lines drawn vertically. All of our horizontal lines are drawn at angles of 30 degrees. Okay, so it's kind of like a three-dimensional object. So it kind of gives the owner and everybody involved an idea of what the building will actually look like. Okay, all the lines of an isometric axis are drawn in proportion to the actual length of your building. Because obviously, if you think about it, when you're looking at something outside, the further away from you, the smaller it gets. This is basically the same idea of what a isometric drawing and what a rendering would actually look like. It's basically giving you a 3D version of what is going to be involved in the final project. Here we have an isometric drawing of literally a plumbing layout of all of our pipes that are actually going to be laid out into. In this case, it's going to be, looks like it's a 3-floor or 3-family house. We have all of our vents. Here's your main vent. Here's your street, and here's your traps for your sinks, your toilets, and all that stuff. So this is what is a basic rough idea of what types of plumbing would be needed to put the plumbing into a home for all of your sinks and your toilets. So this image here gives us an idea of how to begin to draw an isometric drawing. Again, everything is at 30 degrees. So everything has to have a horizontal plane, a starting plan. And then as that goes through, you start to put your lines together, and eventually you can start coming up with a structure. A lot of our isometric drawings are going to be drawn to scale, 1/4 inch per foot mainly, depending on the size of the building. That could be anywhere from a 1/2 inch per foot, 1/4 inch per foot, 1/8 inch per foot. You are going to draw these diagrams of these pictures to represent X amount of feet of building height or length to come up with a total diagram. And this is another idea of what a isometric drawing would look like. Eventually, like I said, it comes in eventually as you put it together, it comes into a 3-dimensional shape. You can do an isometric drawing on anything in your home. Just take a tape measure, draw it, and just draw it three-dimensional. Everything's at 30 degrees. Your oblique drawings are used when an irregular shape is to be shown. The most irregular surfaces are shown in proportion as though it were flat against a drawing surface. Kind of think about like a home, and you took it and you just smashed it against the surface, and it just lays out flat. Okay, all your parallel lines are added to show depth.
Okay, so I will reach back out and then we'll go from there.
Such as, molding in a home. Yes, and when you are in a construction site, you will have blueprints that will show you the design of all the crown molding in a home. It gives you that idea of what it's actually going to look like. You can see in figure A, it's a front view, which is just basically kind of looking at the crown molding from the side. And then you'll have your oblique view, which is like a 3D view of what the molding will actually look like. Orthographic projection is an image, of an object as if you were looking at it in like a glass box. Okay, the corners and lines representing objects' edges are projected onto the box sides. If the box is unfolded, the image is projected onto its sides will be on a single plane as if they were on like a single piece of paper. So each view of an object shows only one side. So like as you can see here, this is an orthographic projection. It's kind of like building a model. You have all of your pieces. Here's your roof. Here's your sides. And if we were to take it and glue it all together, you would actually have a total structure. You would also have another rendering that would show you each side of the home. So here would be like the front portion of the house. Here's our top, and here's our side view. So it gives everybody an idea of what the building would look like from all different areas. Okay, all surfaces parallel to the plane of an orthographic projection are shown in proportional to the actual size and shape. Surfaces not parallel are going to be shown or not shown in their proportions. Okay, so like here's an example of an orthographic projection for a roof. Okay, it tells us on a lot of these types of projections, it's going to give us the pitch of the type of roof. In this case, this is a 12 pitch. This is what a 3. So it gives your idea of how steep the roof is going to be, and it's also going to give you the type of shingles that will be used on the roof. Okay, construction drawing views. Plan views show layouts of objects viewed from above, such as your building floor layout and foundation. Your elevation drawings are going to show you your height of the building, and is what would be seen standing in front of the house, such as what you see here. This is a plot plan. Obviously, you can see here is the view from the street. It will give us our elevation. Okay, in this case, this house is slightly on a hill with a nice little walkway going up to it, and then a nice little tree. How cute, right? And then this would be a bird's eye view of what the building would look like if we were flying over it. So you have your house. Here's your little walkway. It gives us our dimensions. So in this case, this house would be sitting 80 feet back from the street and 30 feet in from the property line. Okay, so it gives you a nice little idea of what it's going to look like. Here we have our elevation, okay, as if we were sitting there and looking right at the house from the front. This is what we would see. Okay, section views show what would be exposed if it were cut, if a cut was made actually right through the object, which is better known as our floor plan. So if we were to take a floor plan and we were to take that building and literally slice it right in half, take the roof right off, we would be having a bird's eye view looking straight down into this home and would give us the layout of what the building would actually look like. So here is that duplex that we were talking about at the beginning of this presentation. Basically, each house is literally mirrored off of each other. They're just opposites of each other. This is what a floor plan would look like. A more in-depth floor plan would literally have all of your dimensions, your layouts, where your doors, your windows, all of that stuff, which you can kind of see in this image here. Here's your windows, here's your doors. But in these homes, you would literally have dimensions on your lengths and your widths of all of your rooms.